This brief video will introduce you to the notions of sampling in observational studies. An observational study is one in which data are collected with the express reason or purpose of gathering information from the perspective of a researcher or from the perspective of subjects who are providing feedback about their point of view in regards to a particular question that data is supposed to answer. What seems to be the problem in our current culture and society is that over the past few years, we have had a deluge of data become available in many different forms that are quite appealing to the masses. We have videos of all kinds being posted by anywhere, anytime, any place. And this has been sold to us with the notion that absolute freedom of expression is actually a pretty good thing because it provides a democratization of ideas and of values and of principles and of the notion of pure expression. However, it also creates a system of data that we call sometimes big data. And it's large amounts of data that really aren't collected or aren't offered to us society in general society with any express purposes in mind. It's rather, it's not really data, it's information. It doesn't have a purpose. And it also doesn't have a proper structure. It doesn't have a who and a what and a why, essential ingredients and elements for data that is very useful in ultimately making decisions or reaching conclusions that are generalizable, that can forward value added, both private and social. And so the notion of big data as such is one that requires careful definition, because not everything that's out there on YouTube or on social media platforms or on LinkedIn or on any platform out there is really data. It's more than anything information. It becomes data only when it has a why, a who, a what, a where, a when. In chapter 8, we talk about data and we talk about the pitfalls of big data, and we talk about how statistics comes up with a solution to data that is useful at answering targeted questions, data that provide us with statistics that offer us the ability to generalize our results, our conclusions, and our decisions from such data sets. And there are two main varieties, one covered in chapter 8 and one covered in chapter 9. Data from observational studies and surveys, in which the perspective of individuals is logged in order to provide evidence towards ideas that we wish to study. And studies of cause and effect, in which we need data sets that are structured as what we call design experiments. And we'll talk about those in another video. So what are the essential components in the architecture of data? And the answer to this is there's three basic ideas that allow us to create in observational studies samples that meaningfully allow us to study really valuable social and private problems and issues and questions and processes. The first is the idea of sampling in a sample. We don't need a lot of data to actually arrive at very powerful insights that apply to a population. We just need a properly constructed sample of data, a part of the whole that is representative of the whole, and that is what a sample is. partial representation of a population or universe of data. The second idea of importance is that of randomization. In order to be able to create a representative sample of data, the representative sample should be constructed by processes that involve randomizing over the population or over the uncensored parts of a population of data in order to create very meaningful representative data sets. So randomization is an important element of these samples. Random sampling is key at being able to construct good data that yields good statistics that provide us with very valuable inferences about populations of data. And the third is, it's not the size of the population that matters in studying data sets that provide statistics that are inferentially valuable. It's the size of the sample that matters. So we could be studying the population of a country the size of India, for example, or we could be studying the population of a country the size of Haiti, as another example. One country has over 1 billion people, the other one has barely a couple of million people. Their size, the size of those populations isn't important. It's how big is the sample that we use to construct statistics that enable us to understand the entire population from the sample. So it's the size of the sample, not of the population, that matters. From these three ideas, we can construct samples that meaningfully help us build statistics that yield inferential results. And the most important structure in sampling, again, the key aspect to sampling is randomization. So there are many different ways that we can achieve randomization. One is called a simple random sample, when the probability of any subject in the population being selected to the sample, being elected or selected to the sample, undergoes an equal probability of selection, a uniform model, so to speak, of selection. A uniform in the sense of uniform probability model. Sometimes, though, we have problems with using simple random samples, such as having a censored part of the population that contains key variants of data that are important. And so we have developed a concept called a sampling frame, which is an important concept to take into account. There are certain populations where the sampling frame is too censored. It censors too much of certain aspects of a population that are very valuable, and as such, that disables us from being effective at producing simple random samples that are inferential. And as such, we develop, as a result, strategies to help us cope with the censoring component of a sampling frame being too limited. One such sampling strategy, alternative to the simple random sample, is the stratified random sample. In a stratified random sample, we segment the population into groups, and each of these groups is composed of very similar elements. So you have a bunch of components, and each component is on a standalone, made up of things that are very similar within it. And then what we do in a stratified sampling mechanism is randomly sample within each of these homogeneous groups. It's kind of like how we should be tasting a buffet style menu. You take a little bit from each plate, and that's how you taste the whole buffet. Other strategies sometimes lend themselves to greater ease in observational studies because the population may not be able to be segmented into microcosms that are very homogeneous, or groups that are very homogeneous. Sometimes we have populations that actually have clusters, but each cluster is heterogeneous. Each cluster is basically a microcosm of the whole. So a cluster random sample consists of a population that can be segmented into groups. Each group is highly diverse within each segment. And so you pick at random a few segments, and that helps you capture the entire population. It's sort of the way we sample pizza. A pizza pie should have the crust, the sauce, the cheese, and all the trimmings. And when you cut the pizza into slices, every slice has a little bit of everything in it. So all you need to do to taste the entire pizza is just pick a slice at random and eat that slice, and you've tasted the whole pizza without eating the whole pizza. So that is a strategy that is akin to cluster sampling. In many other situations, we have to evoke more complicated structures than stratifying or clustering, in which case we use stages in sampling. And these stages can include systematic formats of sampling and can involve other stages, one after another, of sampling. And so these multi-stage samples are typically conducted in complex exercises of obtaining representative data samples for populations when we're answering certain questions with the statistics about these data. And so to close, Chapter 8 introduces the most important issue with respect to these ideas of sampling that I've covered in this video thus far. And it is the whole point of trying to get a representative sample is to try to understand phenomena at large without having to look at or having to have access to all of the data and having to study huge amounts of information, but rather a few, and develop statistics for them that provide inferential value. And in the process of doing so, we sometimes have inevitable problems with this process. And the inevitable problems fall under the guise of one single word, and that word is bias. So what we're trying to avoid when we're randomizing in a sample is we're trying to avoid different sources of bias. And so understanding the different kinds of bias that are defined in the last section of Chapter 8 will be an important part of your reading for Chapter 8 in order to understand that we have sometimes voluntary non-response bias, and we sometimes have censorship that create other complications with our statistics. And more in our control set will be measurement errors and proper use of piloting surveys or proper methods of pilot testing, how we're going to collect our data in observational studies and surveys in order to avoid having issues that will compromise the ability of our data to generate insightful statistics that provide us with what we're looking for, which is extraordinary insights into populations of data. Thank you for watching this video.